Hi, everybody. In this video, we're going to start talking about player movement as we work towards something along the lines of a Pong demo, but I want to look at a variety of ways to control a player's movement in a 2D environment. I do apologize for the background noise. I've got a couple of 3D printers doing some work here that I can't afford to stop, so I'm just going to plow ahead. So I'm here in a 2D environment, and I want to go ahead and create something that's going to work as our floor. So that's just going to be a square. I'm going to go ahead and call that the floor. And I'm going to start by tagging it as the floor, so ground. I'm going to tag it as the ground so that I don't lose that later. To do that, I add a new tag, and I've got to press the plus here and say what it's going to be. And then I have to go back into the floor and then choose that. Oh, there it was. Got to go back into the floor. Sorry about that. Can't read my own list of tags and choose it there. I'm going to go ahead and use W as my hotkey in order to move that ground around. And then I'm going to use my scale tool to spread that out. And I'm going to go ahead and give this a little bit of maybe a grassy color or something. That looks pretty good. You know. And then I'm just going to use for my player, I'm going to, there's my plus sign, 2D object, sprites. I'm just going to use um, a diamond as my player today. Again, W for the shortcut key. Rename that to player. I'm going to go ahead and tag it as my player. And somehow I got into there we go. Zoom out, and then we'll be able to see everything again. There we go. I'm going to move that down. And R to scale, I want that to be nice and kind of tall and player-like. And let's give that a nice, let's go with like a nice purple. There we go. I like that. Okay. Now, in order for anything to work here, I need to have some colliders. That way they'll run into each other. So I'm going to say physics 2D, and I'm going to give this one, I think I'm just going to do a box collider for now. And I need one around my ground as well. Physics 2D, box collider 2D. And for the moment, I'm going to go ahead and add a rigid body 2D to the player as well, because we're going to look at 3 ways to move this player around. We're going to do it just by changing its position. We're going to use the mouse control to change its position. And then we're also going to take a look at how to maneuver the player using physics. Okay, so that requires the rigid body. And I'm going to go ahead and make it kinematic for now, which means it's only going to react in terms of movement, it's only going to do what we tell it to, but it has the ability to have an impact on other things in the scene to a certain extent. So we're going to leave it kinematic so we keep control, and then we want to add a new script that I'm going to call PlayerMovement. Create and add, and it's going to say where to save it. I'm going to go ahead and create a scripts folder in here. Keep everything nice and tidy. And if I go to my project, we see now that I've got the scripts. I can shrink that window up once it's done looking at all that. There we go. And see it as a tree instead, if you want that. Or you can zoom it up and continue to see it as icons. I think it'll be easier for you to see what's going on with it like this, so that's the way we'll keep it for now. I'm going to go ahead and edit that screen movement. There we go. I believe I trust the authors, as I am the author. Now let's go ahead and toss those release notes, and I'm going to reload those extensions. There we go. Player movement. I've got start and update here. Update happens every round. So what I want to do, I want to make sure that I've got access to the input system. And so on the player, I am going to do some stuff with jump, I think. So I'm going to add component, an input, and player input. And that's in send messages mode, which means that these functions it lists here will get sent to the script that is on this object, my player movement script, and I can react to those. But for movement, I want to do that in update. Okay, so I need using Unity engine dot input system. That will give me access to it. And now I need a input action variable at the top, and I'm going to call that move action. And at start, all right, and we're back. So we're going to say move action equals input system dot actions dot find action, and then in quote we're going to say move, and that finds the move action out of the input system. And so it doesn't rely upon specifically being a keyboard. It's looking for axes from a joystick or whatever it is that you may choose. So in our update then, every time through, we can say if the move action does not equal null, then I really want this thing to stop helping me so much, but we're going to plow ahead. Then we want to get the left and right, which is what I want to move. So there are two axes that we can grab in a 2D game, and they're going to be float, so decimal values, and that's going to be move action dot read value, and we're looking for a vector 2, and that gives you two values, an x and a y. So the x is going to be the x. And I'm going to go ahead and grab the y so that we can play around with it, but I'm not really planning to use it right now. Okay, so I'm grabbing the x and the y. And I'm going to print x and dot toString plus comma plus y dot toString, just so we can see what that looks like. Okay. So we're going to go back and play. This is great to test your work along the way. Printing is a great way to get that done. Okay. We press play. We press play. There we go. And we look at our console because that's what matters. Right now we've got 0, 0. Now I've got 1, 0. These are, notice that it's collapsed, so we're seeing a lot of it. If I press straight up and to the right, I get this offset value. If I'm only pressing up, I get 0, 1. Pressing down, it's 0, -1. Pressing left, it's -1. There we go. So I'm getting those values. That's good news. And then what I want to do is change the location of the player based upon that. So I'm going to say transform.position equals transform.position plus new vector 3. Has to be a vector 3 because inside of Unity, it's always X, Y, and Z. And I'm going to say, I could give full motion right now. X, comma, Y, comma, 0. So this should go up, down, left, right, and just move around the screen. I'm going to be fighting gravity right now, so maybe I'll turn off gravity for this rigid body by changing my player's rigid body. Maybe it's not going to matter because I'm kinematic. So I did make it kinematic, so that shouldn't matter. All right, so if I go to the right, look at how fast that is. We got to slow that way down because, of course, we're only doing a few points anyway, and update happens a lot. So we can modify these values. Times time dot delta time is a really common way to do it. That's the amount of time that has passed between frames. And then we'll create a variable called speed. I haven't set it up yet, so it's going to complain for a moment. But I'm going to come up here. Let's get rid of that. So I've got my float speed equals, let's try 5 to start. By putting the F there, we tell it that we mean a float value and not something else. It's a good habit to get into when you're working with Unity. All right, now maybe we'll be able to see what's going on. There we go. So I can go left, I can go right, I can go up, I can go down, and I can go diagonals. I have pretty complete control over this player right now. If I only want to be on the ground and maybe be able to jump, then I probably want to change that Y to a 0. And then it's not going to matter what I do on the Y. And I could, if I want to, I could get rid of all the references to it. Okay, so left, right, up and down are doing nothing, and that's it. Okay. Let's go ahead and let's do a mouse control instead. So that's a little more similar. One of the things to note about this before I do that is that by changing the transform position, we're doing kind of micro teleportations, and we're not really doing physics at this point, right? So let's say I put in an obstacle, a 2D object, a sprite, we'll make it a capsule, and we'll go ahead and scale that down a little bit, and we'll move it down, and we're going to add a collider to physics 2D, and we'll call it a capsule collider 2D. So I've got a collider, it's got a collider, we should run into each other, and I go right through it, right? Whereas if I come up and grab it here and over here, and I change, this is all while I'm playing, so these changes are going to go away. Change that to dynamic. It does run into it, but when I'm moving it around, it does not. So that's because I'm doing teleportations and not force. We'll solve that later. All right, so let's do float mouse control. No, not float. Boolean mouse control equals true. And I'm going to go ahead and serialize that field so that I can see it in Unity. So if I'm on the player and I have a variable that I've said serialize field on, I can then control it from within Unity. Okay. So if mouse control, all right, so if we've got mouse control, then we want to get the X as the mouse dot current dot position dot read value dot X. Okay. And then we want a semicolon at the end of the line. And we're going to do the same thing here, dot Y. And we're again going to make sure that we get a semicolon. Okay. So to get the value at the X and the Y of the mouse, we do mouse, capital M, dot current, dot position, dot read value, and then we can grab the other pieces. Okay. And then we can say transform dot position equals new vector 3 x y 0. So that should just put it wherever the mouse is. It's not going to work yet, and I'm going to show you why. We're going to stop the play that was failing, and instead there we go. If I come all the way down here somewhere, we can see that the value is changing, but it's not showing up. If I get, so there, I'm watching the values into this area. Maybe it'll start to show up. There we go. So we see that my range of movement is tiny because, of course, the mouse input is showing where the mouse is on the screen. And it's trying to work from the world, and the world is on a very different scale, the game world. So what we do with each of those is we adjust it by doing this. We can say x equals camera.main dot screen to world point. X. Oh no, screen to world point. I'm sorry, I'm totally doing this wrong. Wants the position. Okay. And it's got the other pieces. So I need to adjust how I'm doing this. I'm going to take this vector screen to world point returns a vector 3. Vector 3 mouse loc equals camera.main.screen to world point mouse.current.position .read value. Okay, so I'm just grab that. I'm going to toss this, and I'm going to toss this. But then I can grab out of the mouse location the other pieces just by doing this. Mouse loc.x, mouse loc.y, 0. I missed a semicolon over here. Yes. Now I've got that back. So let's toss our side piece here. So if mouse control, then the mouse location is camera.main.screen to world point of the mouse's position. And then we set the object's transform position to that. Okay. Maybe we could just say the mouse's position, but we're going to specify that because later we might choose to lock it in on a certain space. So now it just follows the mouse perfectly exactly where I want it, right? Notice that it does not do any collisions in there, but it's pretty good, right? If I wanted to keep it at this location vertically, that's negative 3.28. I would just say, instead of mouse loc.y, I would say negative 3.28 f. And now you can see that that player just stays there. It doesn't matter where my mouse is. The last thing we want to do for mouse control, if that's what we want, again, you're making choices based on what you want out of your game. In start, I can say if mouse control, then cursor dot visible equals false. And that will let me hide that mouse and make it feel like I am just controlling the player. Watch this. Once I click in, it goes away, and it's just side to side, up and down don't matter. If I want my mouse back, I can press escape and come back up. Okay? So we have keyboard control, we have mouse control. Let's do it with physics instead. So mouse control is one option, keyboard control is another, or any kind of controller control. So we'll go ahead and turn mouse control off. And then what we're going to do is we're going to say, we'll do another one, comma, physics control equals true. So if physics control, then that, and else we'll do it the way we did before. And this will allow us to demonstrate all three ways, right? So we still want these values. So I'm going to actually put these up here because we still need our x and our y. Well, we need our x anyway. So with physics control, we need the rigid body. So we say rigid body 2D. If I'm going to use this a bunch of times, I could do this work so that this is a global variable. But right now we're just going to do this. Get component rigid body 2D semicolon rb dot add force x new vector 3 x comma 0 up and down and 0 forward and back. And then we're going to do force mode 2D dot force because this is in update, so it's happening constantly. Okay. And we'll take a look at what this does and see what we have to do to make that x smooth out. Okay. So let's check our variables here in our inspector. Remember, we serialized those fields, so they're going to show up in here. I'm going to turn off mouse control and turn on physics control. And we play. Not much is happening. Okay. So we got to check and see what, oh, my body is kinematic, so I need it to be dynamic. And then the other thing that I want to do in that case is go into constraints, and I'm going to freeze that Z rotation, otherwise that diamond's just going to fall over. We're going to stop. We're going to do that outside of play mode, and then we'll get this figured out. Save and play. We are getting nothing. So let's see if we can figure out what's going on. RB add force needs a vector 2, not a vector 3. I apologize. Maybe that's the problem. And that should do it. So we're going to try this again. We'll check. We got mouse control. We got physics control. And it is still not working. I apologize, y'all. We're just going to take this out. X equals. We've got that. Oh, it's small. So, but it should still be making changes. Checking that our rigid body is dynamic. Nothing is changing. So I'm gonna get rid of this stuff. And we'll start seeing if we can add some more force. There we go. Now we've got it. And what you'll see is then we actually run into that thing and we get better control. And then the last thing we're going to do is make our player jump. You can change the power. I just was not getting enough force out of that by doing the time delta time. I was adding like a 12th. Not going to do it. So take care of that jump, remember we added on this not the player movement, the player input piece. So that allows us to say public void on jump. And then we can say we're going to take this same kind of thing and we're just going to change this to 0 on the X, and on the Y we'll go ahead and add 1F, and we're going to do this at force mode 2D dot impulse. I had the wrong force mode over there. That means that it's just going to happen all at once. because that's the way the jump works. And maybe my value is going to be too big, but we will find out. Maybe it's too small. We can see that it's trying, right? Okay. So to fix that, we're going to come up here and we're going to do another serialized field. And we're going to say float jump power equals 5F. And we're going to take in jump. We'll just do this as jump power. And that'll let us change it in here. Again, we serialized the field so we can control it inside of Unity. Our level designers, in this case ourselves, get control over it. All right, there we go. That's a little better. And currently, we got one more thing to do to fix that. And that is that we can jump no matter what, so we can basically fly, right? Every time I press spacebar, it does it. I only want to do it if I'm grounded. So I'm going to add a new Boolean called isGrounded as false. And in here, I'm going to say if is grounded, delete, tab. And when we do that, we're also going to say is grounded equals false. Now, when does it become true? We're going to do a void, we're going to do an on collision enter, 2D. And we need to check collision dot game object dot tag equals ground. Remember, we tagged it with ground, then is grounded equals true. So when we run into the ground, we're going to turn that on. We are kind of constantly hitting it here. So we play. And that should be enough to stop it from jumping in midair. I only get one jump at a time. Okay, so I can, if I jump, it works. If I press multiples, right, you can hear me clicking that keyboard, that space bar, I only get one at a time. So I get control over the jumping ability. I have control in 3 different ways of moving around. I could do it by the keyboard or another controller. I can do it with the mouse. And within the controller, I can either do it in this teleportation mode or with physics. The physics way works a lot better with the jump because it means that it keeps its momentum and has a nice natural arc to it. That's all we're going to do today. Thanks, y'all.